As many of you know, Ruby has what's called leftward assignment. That is, the thing on the right gets shoved into the thing on the left. Now, Ruby also has what's called rightward assignment. The thing on the left gets shoved into the thing on the right. Now, this was a relatively recent addition to the language. I think it was around Ruby 2.7, and it was later merged into Ruby's pattern matching support. But when it first came out, a lot of people were understandably upset. And I think it's clear to see why. It makes no sense whatsoever to have leftward assignment and rightward assignment in the same language without also introducing the obvious downward assignment. Now, as far as I know, the Ruby core team has made no moves to add this obvious feature. In a lesser language, we might be stuck with this heinous oversight. Thankfully, this is Ruby, the language whose unofficial motto is, of course that's possible. And so, I give you this talk, Vertical Assignment in Ruby. My name is Kevin Kuchta, and because my parents never taught me right from wrong, I'm going to walk you through implementing the language feature that no one asked for, and in fact, several people have begged me not to. I'm glad that you're, thank you. It's really a good thing that you're all already wearing masks, because some of the code in this talk is so bad it might be contagious. Please, please do not try this at home or in your production code bases, unless it's funny, in which case, at me on Twitter. With the disclaimers out of the way, the first thing you have to figure out when you're trying to create some new awful operator in Ruby is, what is that operator? You know, what goes here? And my first thought is, maybe some sort of rotated equal sign, right? And okay, maybe we could do that with 2 vertical bars, which is, of course, already the Boolean operator in Ruby, the Boolean OR operator. Well, of course, it's already in use. Maybe we could override it somehow. I mean, we can override the addition operator. Here I am overriding the addition operator on the integer class so that all integer addition now returns 3, because 3 is the best number, and why would you ever need any others? Unfortunately for us, although probably fortunately for the rest of the world, the OR operator is not one of the ones we can easily override. But we are not without options. A cool thing about Ruby is that it's very permissive about what you can put in identifiers. And by identifiers, I mean class names, variable names, method names, that sort of thing. For example, did you know you can put emojis in identifiers? Here I have defined a method whose name is, instead of being 3 characters, 3 letters, it's 3 tacos, which is obviously strictly better. Now, if you can put emoji somewhere, you can generally put other sorts of Unicode nonsense in there. So all we need to do is find some Unicode nonsense that looks like a rotated equal sign. And after a little bit of Googling around, I found this little guy. This is the double vertical line character, and it looks suspiciously like a rotated equal sign, which is what we want, right? Now, I'm told that in real life, this character is used to indicate the norm of a matrix. Now, I have no idea what that means, but we are going to be using it to indicate our own moral turpitude, because we are going to create this, a functioning vertical assignment operator in Ruby. And thankfully, this is already syntactically valid. Ruby will go through this line by line and say, the top line, so it's syntactically valid, but it doesn't run. And so Ruby will go through this line by line, will hit that top line, that 3, and say, okay, this is just a valid expression. It's a numeric literal, that's fine, let's move on to the next line. But then it will hit our vertical assignment operator and say, you're trying to reference a method or a variable that happens to be named this weird character. And you haven't defined that, so what the heck, you jerk. And okay, fair enough. If Ruby thinks this is an undefined method, let's define it. Here I've defined a globally available method whose name just happens to be the Vequals operator. And sorry, I'm jumping ahead of myself. I'm getting tired of calling it the vertical assignment operator. Let's call it the Vequals operator, short for vertical equals, because maybe if that's like clever and pithy enough, we can convince someone to sneak this horror into Ruby core. Now, I have defined this Vequals method. It takes any number of arguments and does nothing with them. Which, okay, great. Ruby will hit the second line and say, all right, you're calling a method. The method is 1 character. You're passing no arguments to it, and it does nothing. Great, let's move on to the 3rd line. Then it will hit the X and say, well, crap, this is not defined either. And this is a problem for us. Because in Ruby, leftward assignment, it doesn't just assign 3 to X, it also declares X as a new variable in the current scope. Same thing with rightward assignment. It makes X out of nothing. And we need to do the same thing for our vertical assignment. We need to declare X somehow. To do that, we are going to use a tool that is wholly inappropriate for the task. If this problem were a twig, we're going to use a chainsaw. It's time for TracePoint. Now, TracePoint is a really cool tool. it's built into the Ruby standard library, and it lets you sort of react to other things happening in your Ruby program. Let me give you an example. Here I'm setting up a tracepoint to react to any time you raise an error. I do this by calling tracepoint.new, passing it the symbol raise, then giving it a block with something I want to do. Then after I've enabled this tracepoint, anytime I call raise, this block will be run. And there are other cool things you can do too. In addition to just listening for raise events, you can also listen for anytime a method is called. You do this by calling tracepoint.new and passing it the symbol call. And now anytime you call any method anywhere on Ruby after you've enabled this tracepoint, this block will be evaluated. Now, there are a bunch of other sorts of things you can have tracepoint listen for besides just method calls and raises. You can have your tracepoint block run every time you start a new class, anytime a method returns, anytime a thread finishes. There's a whole big list. But if, like us, you're trying to really rip open the fabric of Ruby space-time, you can run tracepoint on every single line. You do this by calling tracepoint. That is the correct groan. Tracepoint.new, give it the symbol line, and give it some block. And after you enable it, any line of Ruby, no matter what, will trigger this line. And one thing that will be important later, so I'm going to mention it now, the tracepoint block runs just before the line that triggered it. So on this first line, x equals 3, just before 3 gets assigned to x, it will print out tracing line 6 in file tmp.rb. Now, the tracepoint block is given a little variable that I have, or an argument that I'm calling TP as a subtle nod to how crappy our code will be. TP has a bunch of information on it. Here we have the line number and the file path of the line that triggered tracepoint. There is some other information it gives us too, specifically the binding of that line. Now, if you've not run into bindings before, there are these cool, nearly magical objects in Ruby that act as a sort of reference or a pointer to the scope at a given point in a Ruby program. Let me show you how it works. The usual way, ignoring tracepoint, the usual way to get bindings is to call the globally available binding method, which will create a new binding at this point in the program. Let me show you how to use this. So I've got some method, and it has a variable inside of it, and all it does is create a new binding and immediately return it. Well, after this method, if I try to print out x, of course it would say it's undefined because x is only defined within this method. However, if I grab a reference to the binding returned from this method, then I call that binding.local variable get, it will actually give it to me. It will give me this x variable. I think this is extremely powerful. It lets us throw the usual rules of scope visibility to the wind and access variables that would otherwise be totally inaccessible. I think this is extremely powerful, and we are absolutely going to go mad with that power. So let's get back to our Vequals nonsense. We're up to the point where the first 2 lines work, but x is still undefined. What if we had some way to, right before Ruby hits this undefined variable, define it at the last possible second? Like a locomotive hurtling down a train track, and at the last possible second, building the track in front of it so it never quite crashes. What if we could do just-in-time variable declaration? And I mean, think about it. We already have a way to run code before every line of Ruby and to mess around with the scope of each of those lines. Maybe it would look something like this. We're going to register a tracepoint to run on every single line, and when it does, if that line includes x, we're going to define it in the local binding. Now, unfortunately, there are a couple problems with this. Beyond the obvious ones like, oh God, what have you done? Why would you do that? The first real problem, to my mind, is this bit here, tp.line. This method does not exist. I made it up. Tracepoint gives us a lot of useful information about every single line that triggers it, but it doesn't actually give us that line as raw source code. But we do have everything we need. We have the line number of the line that triggered the tracepoint. We have the file path of the line that triggered the tracepoint, and we had, you all see where I'm going, and we have the most important thing of all, no compunction against doing terrible things in Ruby. So you know what? To hell with it. We're just going to read the file from disk on every single line of Ruby and grab out the line that we need. Because why not? I can think of nothing wrong with this, aside from the fact that it is incredibly slow. And yes, it does completely break REPLs, but we're going to charge ahead because it works. It solves, in the loosest sense of the word, our problem. Source code access within tracepoint. But I did say that there were a couple problems, and the other one is here. Local variable set. This method does exist on binding, and it kind of works how you might think it works. Say you've got some scope, and you have a variable in that scope, x equals 3, You create a new binding within the scope, and then you call that binding that local variable set to update this value dynamically. Totally works. I think that's pretty cool. But it doesn't work for new variables. You cannot create a new variable within a binding. If I had to guess, this was meant to prevent exactly the kinds of shenanigans we are trying to pull. Like, imagine if you could just insert, if anyone who had a handle on a binding could just insert brand new variables willy-nilly. It would be utter chaos. Although, to be clear, we are going to do exactly that anyway. Now, I would like to tell you that I know a dark, secret way to declare variables within a binding, but I don't. So I'm going to take the coward's way out and just define a method that is hard-coded to return the value that we want. Great. And hey, look at this bottom line, puts x. It kind of looks like x is a variable, right? And hey, I can still totally assign a value to x anyways, and it will continue to look like a variable. So as long as you all don't tell anyone it's a method, and I don't tell anyone it's a method, we can continue on with our charade that it's actually a variable, with everyone else none the wiser. So, we have our two fixes. We know how to read lines of source code in TracePoint, and we know how to declare new variables, wink, wink, nudge, nudge, within a binding. And yes, these are both terrible hacks. No, we will not be stopping. Now, we have two wrongs. Let's see if we can make a right. And this worked. This is a success. On each line of Ruby, we check if that line includes x, and if it does, we define x, just-in-time variable declaration. Let's try to make it a little bit more generic. Here I'm taking each line, splitting it apart, and looking for anything that looks like a variable. If I find something that looks like a variable, I define it. And this works. True just-in-time variable declaration. We need never again fear the tyranny of undefined variables. Method missing errors, they're a thing of the past. You should implement this in all of your code because fewer errors is always better, right? But all right, you can perhaps already see some limitations on this. And not just that the basic idea of automatically defining all undefined variables is ludicrous on the face of it. The problem I see is that this line splitting technique, where I take the line and split it apart by spaces, that's incredibly brittle. There are a bazillion different kinds of Ruby lines that would totally break that, including, for example, one that includes the pound sign. This will split that line apart and come up with a whole bunch of things that we'll try to define as a variable, most of which are not variables. And so yes, I could teach this code that anything after the pound sign should be ignored. I could also teach it to ignore Ruby keywords, and I could teach it about parentheses and brackets and everything, but that's starting to sound like a lot of work. And one thing that anyone who knows me will tell you is that I am extremely lazy. My goal in life is at all times to do the worst possible thing with Ruby with the least possible effort. And what we really want here, it seems like, is some way to take a line of Ruby code and explode it apart, break it into all its pieces, and tell which pieces are the identifiers, the comments, the literals, and so on. Thankfully, there are tools for exactly that. I would like to introduce you to Ripper. And no, I don't mean the Victorian-era murderer, although, to be clear, we will be using it to commit crimes against code. Now, Ripper is a pretty cool tool built into the Ruby standard library, and it's meant for parsing Ruby scripts into data structures. The usual way you would use this is by calling ripper.sx, which will produce s-expressions. S-expression is a fancy computer sciencey term for a nested data structure representing this code as syntax. If I sx this little bit of code, I get this blob of stuff. It's pretty dense, no need to look at it too closely, but you can kind of see that it sort of resembles what we put in. There's an outer level program, there's an identifier, there's some integers, there's some binary stuff, whatever. It looks like it's our line of code broken out into its component pieces. However, this isn't quite useful for our purposes. There's a problem with Ripper.sx, and that's that it expects to be given a complete program. And by that I mean one where every def has an end, every open parenthesis has a close parenthesis. And if you don't give it that, it will just sit around forever waiting for the end to come and then just return nil. So to get around this, we need to take a closer look at what Ripper is doing under the hood. Because Ripper is a parser, and parsers, very loosely speaking, have two major steps. The first is to go from this top line to the middle line, which is to break apart the line of code into the chunks that are meaningful to the programming language, in this case Ruby. Then they take this series of chunks in the middle and turn them into this big, deep, nested structure. And that middle line, it kind of looks like what we actually want, right? The line of code broken apart into its component pieces. Thankfully, Ripper exposes the ability to get exactly that with ripper.lex. Lex is short for lexicographical analysis, which is a fancy term for breaking something apart into meaningful chunks. Those chunks are often referred to as tokens, and therefore it's often just called a tokenization. And remember how earlier we were taking a line of Ruby code and splitting it apart by spaces? What I was really doing here was just some really janky, busted kind of tokenization, just a really wrong version of it. So let's replace it with a proper tokenization. We call ripper.lex, and that returns a big list of tokens. We iterate through these tokens, we exempt the tokens we don't care about, and define everything else as a variable. All right, we're on the right track, but I still have to manually remove puts and white space, and presumably a lot of other tokens. So let's take a closer look at what ripper.lex actually gives us. If I were to lex apart this one line of Ruby code, it gives us this big list of tokens. And for each token, it gives us 4 pieces of information. The first is the position of that token. This is the line number and the column number. Next is a bit of information about what kind of token it is. Then there's the token itself as a string. And finally, a bit of information about the tokenizer's state at this point. We're going to ignore that for our purposes. Because what I really want to focus on is this one right here. It's a symbol telling us what kind of token Ripper thinks it is. And this one is the foo token, and it thinks it's an identifier, hence on-ident. The next one is a space, so on space. The next one's an operator, so on op, and so on. And this seems like it could be useful, especially the identifiers. Because remember, we wanted to take a line of Ruby code and break it apart into all the component pieces and find the variables so we could just in time define them. Well, all right, here we are back in our TracePoint bullshit, where we lex apart each line into tokens, and then for each token, we check if it's an identifier. And if it is, we define it to be 3, because 3 is the best number. Now, this almost works. It's really close, which is to say we have completely destroyed the built-in puts method. Because this is going to say that X is an identifier, so it will define that, but also puts as an identifier, so it will define over on top of the puts method. Well, hey, who needs to print things out, right? All right, we sometimes do, so let's make this a little bit smarter. Here I'm doing the same thing. I'm going through each token, finding the identifiers, and then I'm checking is that identifier already defined in the current scope. And if it is, I ignore it. But if it's not, I define it. And hey, this works. True, generic, just-in-time variable declaration with none of our janky hand-rolled tokenization. I mean, there's plenty of jank to be had here, don't get me wrong, but just not that specific jank. But all right, let's get back to our awful, awful, awful goal, the Vequals operator. We're up to the point where the whole thing at least runs. That 7 line, it's always worked. The Vequals operator works because we defined it as a method. X works because we just in time defined it. Now, it doesn't do what we want, but it doesn't crash, which is a step in the right direction for us, and a step in the wrong direction for anyone else who might have to deal with our metaprogramming nonsense down the road. Now, we want to make sure that 7 gets assigned to X. This is going to become a little more complicated than I can easily fit on one slide, so let's take a look at the high-level approach. We want something like this to work. Let's break it apart by lines and columns, because that's how TracePoint and Ripper will see it. And TracePoint is going to trigger on each of these lines, and starting with the top one. But actually, I tell a lie, Ripper will skip over this line because it's just illiteral. It's just a single expression that does nothing, it calls nothing. Ripper will just skip right over, or TracePoint will skip right over it and fire on this line instead. Now in this line, we're going to, when we hit this line in TracePoint, we're going to lex apart this line looking for any identifiers that happen to be our Vequals operator. If we find them, we're going to back up a line and lex this line apart looking for expressions. We find one, we're going to stash the column and the expression that we found, and hey, we found a Vequals operator on column 1 pointing to 7. But actually, we don't want the expression 7, we want the value that needs to be assigned. So let's turn that string expression into a value by just evaling it. Why not? The string 7 evals into 7, and great, we're done with this line. Now we go to the final line, and this time we're going to lex it apart looking for any identifiers. We will find one, the foo identifier. It happens to span from column 0 to column 2. Now we want to check, is this identifier below a Vequals operator on the previous line? We know that it is because we know there's a Vequals operator on column 1, and foo spans 0 to 2. 1 is between 0 and 2. Therefore, yes, this foo identifier is below a Vequals operator, and we need to do our assignment. We do that with our just-in-time pseudo variables, and we just define that identifier to be equal to that value that it's pointing to. In this case, def foo returns 7. And this is really the whole process. It's 2 steps on every line. Look for any Vequals on this line that we should process. Then look for any identifiers that line up with Vequals from the previous line. Here it is, put it together, no need to look at this too closely. It's just the whole thing we've already seen wrapped in a class because, hey, we have some standards. We need to avoid polluting the global namespace. It's got the 2 major steps, checking for Vequals on this line and processing any Vequals from the previous line and a handful of helpers. And here's the whole thing in all of its glory and terror, just the bits we've seen so far, Ripper and TracePoint. No need to look too close because you'll probably hurt your eyes, and not just because of the font size. But the upshot is, it works. Once we've enabled Vequals, we can assign 7 to foo and print the result, and it will totally do what we expect. But we're not stopping here because no, this is far too reasonable. We can, for example, have multiple Vequals on the same line. As long as every other line is syntactically valid Ruby, we're good to go. Heck, we can mix and match our Vequals operators, because why not? But hey, the real strength comes when we combine it with other forms of assignment. Now witness the power of this fully armed and operational Vequals operator as we create waterfalls of assignment. This works, I swear. Foo will end up in C. Heck, we could use it as some sort of ridiculous spread operator. Heck, I won't tell your coworkers if you don't, but hey, speaking of our coworkers, we can leave fun little puzzles for our team, who will no doubt thank us for brightening up their day when they find this in 3 months in the production code base. Do you know what gets assigned to Z here at the end? Because I sure as hell don't. And obviously, the logical conclusion of this, I'm going to tell my kids this is what software architecture is. The only limit is line length and good taste. And hopefully by this point in the talk, it's clear I have exactly one of those things. Now, obviously we have to take it one step further with upwards assignment. Unfortunately, I don't think it's possible. It seems like it would violate causality. But of course, I realize that by saying it can't be done, one of you all will have figured out how to do it before I make it to the end of the talk. So I leave a few of these as exercises for the reader. And to be clear, I'm actually only half joking here. If one of these seems possible, or like nearly possible, go for it. Because the value of a project like this isn't really to produce a production-ready vertical assignment operator that you would use in your day-to-day job. Rather, it's as a way to stretch yourself. Pushing the boundaries of what seems like it's possible with a language, or any tool really, is to my mind one of the best ways to understand that tool more deeply. It lets you use things like Ripper and TracePoint that you might not have come across in your day-to-day job. I certainly hadn't until I did this project. It lets you grow your toolbox of techniques, and I think it makes you a better developer. And personally, it lets me burn off my desire to write this kind of horrible nonsense in my free time so that when I go back to work, I write nice, boring, reliable code. But yes, in your spare time, get weird. Because my favorite thing about Ruby is that it lets you get weirder than any other language. Now, I would like to do Q&A, but because I like the sound of my own voice entirely too much, I will be providing both. Now, the first question I always get when I do this sort of horrible cursed code is, who are you and why have you done this? Well, okay, my name is Kevin Kuchta. You can find me at various places online. Feel free to reach out. I love chatting. I especially love hearing about other people's cursed code. Now, because many people just can't help but rubberneck at a car crash, everyone often asks, where can I see this code in more detail? Well, you can find this on my GitHub. It is the exact same code with the exact same number of bad ideas, but a lot more comments. Now, the question I often get that you would think I would never get, but somehow always do is, should I use this in production? And hopefully by this point in the talk, the answer is clear. Absolutely. Please do. Tell me how it goes. It will be hilarious. Unless you're one of my coworkers. Now, if you are tired of hearing me talk to myself and have an actual question, feel free to hit me up after the talk. I will be around, also on the conference Discord or online, or really anywhere you can find me, anywhere you can track me down, no matter how hard I'm hiding. And finally, there's one more question that I'm sure is burning on all of your hearts, and that's, Kevin, can you please give me a 20 to 30 second pitch for your employer? Well, yes, thank you for asking. I totally can do that. I work for a company called Daybreak Health. We do mental health for teens, and it is easily the most fulfilling job I've ever had. We have saved people's lives in the 5 months I've been there. We are a 9-person company with 2 engineers and 3 code bases. This is too many code bases. please come work with us. We're looking for a senior full stack or back-end engineer. But yes, we're great. You should come work for us. And anyway, that is the talk. I hope that you enjoy the rest of the conference. I hope I've inspired you all to greater heights of Ruby hackery. Thank you for coming.